Okay, the room is a little dark because I want you to be able to see what happens to that light. In this case, I have this hooked up to my board, which is multifunctional. It has LEDs, it has capacitors, it has resistors, it has a light bulb holder, it has a battery holder, in which case I only needed one battery, so I jumped it, and it has a 1950s capacitor over here for measurement. And in this particular case, I'm using this as the power supply to charge what is known as a decade box, which is this thing, and it's set to 500 nanofarads. So what I'm going to do here is charge the decade box and discharge it through this ballistic galvanometer. Now the ballistic galvanometer reads current in the nanoamp range, believe it or not, and it's very sensitive. It's 1930s technology and it's relatively small and compact. If you were to buy a ballistic galvanometer now, it would be about 3 feet tall. It would cost you between $500 and $600. But in the 30s, they were relatively common and compact. So when these things bust, they're gone. We can't really fix them. So we got to be careful with them, obviously. But they do come on eBay as schools foolishly sell off their equipment because they now have multimeters that will read capacitance, but it's a good measure to get standards. Okay, so I'm now going to charge, and it doesn't take long because we're in the nano range, and now I'm going to discharge. And you saw a deflection of the light as the current passed through as this decade box discharged. So what we would do is we'd set it up, and we could, in this case, probably add another battery to maximize the span. But we'd charge it, discharge it, we'd measure the maximum swing, and then we'd set up a linear curve where we could actually calculate unknown capacitance against known. This is how they did it in the 30s and in lab settings up until about 10 years ago when the meters came out. And it's still a practical way to talk about instrumentation and the limits of instrumentation today.